In the previous experiment, we measured emission spectra from atoms. There are many more allowed transitions in molecules, and we will study the row vibrational absorption spectrum of HCl, DCl, and their isotopic variations in order to calculate details about their molecular structure. To measure the row vibrational spectrum, a Fourier-Transform infrared spectrometer is used. The construction of this instrument consists of a coherent light source and a Michelson interferometer. As one of the mirrors is moved, it creates an interference pattern in the recombined beam, which is passed through the sample and measured. Taking a Fourier transform of the transmission signal versus mirror displacement produces the row vibrational spectrum. In this experiment, you will use an FTIR to obtain the vibration rotation spectrum of HCl, DCl, and the chlorine isotope substituted variations. You'll determine the vibrational frequencies, the rotational constants, and the vibrational anharmonicity correction terms, as well as calculate the equilibrium bond lengths and bond force constants for each molecule. As you can see, most of this is calculating, so this experiment is very short in person. This is the FTIR instrument. The sample cell is stored in a desiccator, which you can find in a cabinet underneath the computer. This sample cell is likely different than for FTIR measurements you may have made in the past. The body and inlets are made of glass to contain the gaseous samples, but the windows at both ends are made of potassium bromide, which transmits IR light. These are very moisture sensitive, so please make sure not to touch them and store it in the desiccator when not in use. As you can see here, I'm handling it by the body and by the gas inlets in order to avoid touching the windows. Place it in the instrument very carefully. The sample cell will have been filled for you by the TAs. HCl and DCl gas cylinders are used to fill the sample cell, as you can see here. If your FTIR signal is very low, the sample cell may need to be refilled. Using the FTIR software, you'll collect the spectral data. Here is an example of a zoomed-in region of the data. Try to resolve as many of the finely split peaks as you can and save your data before leaving lab.